Hi, welcome back to LeetCode. So in this video, we discuss LeetCode problem 3618, split array by prime indices. So you are given an integer array nums, split nums into two arrays A and B using the following rules. Elements at prime indices in nums must go into array A. All other elements must go into array B. So we have to return the absolute difference between the sums of two arrays, sum of A minus sum of B, absolute value. Okay. So prime number, they mention that greater than 1 with only two factors. 1 and the suppose x is prime or not. So the condition is that it will be already divisible by 1 and the x itself. Correct? Only two factors. So then x will be called as a prime number. Now suppose for this example 1, 2, 3, 4. So the index 0, 1, 2. So on which condition we have to split the array? On the basis of the prime. If the indices is prime, then it will go to the part of the string like array A. Otherwise, it will go to the array B. So first number, it is actually index 0. So is it prime? No, because for prime, the number x should be greater than 1 and the factor will be only two factor, right? So x is not a prime number, so it will actually suppose A and B. So it will be part of B. So the value will be added to in the array B and the value is now 2. Next is index 1. So is it prime? No, because the still actually it is less than equal to 1, but our prime number should be greater than 1. So this is part of, it will go to the into array B, so it will be added to array B. Okay. Next is index 2. So is it prime? Yes. So it will go to the array A. So here actually the sum, the number it is present in the array A, it is 4. So the sum of this actually it is 4 and sum of array B it is actually 5. So what is the difference? 5 minus 4 it is actually 1. So that's the output is 1. Clear? So here actually for each index, like for I is equal to 0, I less than n and I plus plus, we have to check that is prime. What will be the prime? I is prime or not. If it is true, like if it is prime, that means the sum will be added to in the array A, else it will be added to array B, nums of I. This is clear? If it is prime, clear? So how can actually effectively we can actually check that any number actually is prime or not? So in the brute force approach, what actually I can do? I can actually check that I'll call a helper function. It will take one number x. I'll check that if x is less than equal to 1, so return false. It is not a prime number. Else, what I have to check? I have to check that like from 2 to x minus 1 is a divisible, like current number x is divisible by any I. So I is between 2 to x minus 1. So if it is divisible by I, so that means this is not a prime number. So I'll return this. This is a false. So after checking all the elements, if it is there is no element that is divisible by it can divide the current number x, so that means it is actually prime, right? So that's why ultimately at the end I have to return true. Clear? So this is the brute force. So for each number, for each index, I have to again iterate this. So this is actually brute force approach. How can we use this? Like we actually have some optimal algorithm. So that actually called Sieve of Eratosthenes. So this approach actually effectively pre-calculate all the numbers actually prime or not. So first of all, I know the range. So from 0 to n minus 1, I will actually create a vector. So initially I mark this actually all are actually true. That means actually all are actually prime. So I'm just actually iterating the this algorithm, but we have already used this algorithm in many problems. So you can also check that. So what actually I will do? So 0, 2, 3, 4. So initially I know that 0 and 1 actually it is actually not prime. So I will mark this as a false. Okay, true means prime, false means this is not a prime. So if it is, so again I'll start from 2 to n. Okay, so I'll check the current number, it is true. That means this is actually prime. So that means like 2, if it is 2 is prime, then 4 will be prime? No, because 4 will be divided by 2. Then 6 will be divided by prime? No. So that means the next number 2 into 2, the 4, then 4 plus 2, then 6 plus 2, then 8 plus 2, all the number will be false. So I'll actually iterate this as a false. Got it? Now next is 3. So prime 3 is, yes, still it is true. So that means this will be still prime. So next, which number will be inverted, like which will not be prime number? So that will be 3 into 2, that means 6. Then 6 plus 3, 9. Then 9 plus 3, 12. It will not be prime. Right? In this actually all the order actually plus 3, all the number will be inverted. Right? In actually plus 2, clear? So that means if current number prime of I is true, so next number which will be actually inverted, so that will start from 2 into I, j less than n, and it will be increased by always I. Clear? And mark this as prime of j as false. So this is actually the optimal approach to find any number actually is a prime or not. So this actually algorithm is called actually Sieve of Eratosthenes. Eratosthenes. Got it? So let's go to actually code. So that means in the pre-calculate, by using that Sieve of Eratosthenes, I actually pre-calculate that which number actually prime, which number actually not prime. So for n, I'll actually pre-calculate. Initially I'll mark this all as true, n plus 1, and I know that 0 and 1 actually false, not a prime, so I'll mark this as a false. Now from I is 2 and I less than n, I'll actually check that if the current number if the current number is true, so that means next which number will be not prime, so that will start from 2 into I, and it will be increased by always I, interval of I. Got it? And I'll mark this as false because this is not a prime. So after this for loop, I actually in the prime vector, I can easily say that any number actually like prime of I actually is any random number I, it is true or false. True means this is prime, if it is false, that means this is not a prime. Okay, and I in this problem statement, I have to have two array. One is array A and another array is B. So ultimately I have to know the sum of that each array, sum of A and sum of B. So that's why I will take two variables, sum of A1 and sum of 2. Initially it is 0, and I am iterating the each index 0 to n. So I'll check that the current index I, it is actually prime, so that then it will go to the actually array 1, that means array A. So the sum will be added to the sum 1, the current number will be added to the sum 1, else it will go into the array B, so it will be added to the sum 2, the current number will be added to the sum 2. Got it? So after this for loop, you can say that actually you are checking the index value, the prime I is the index value, so current index actually is a prime or not. Got it? So after this for loop, I actually have two variables. In the sum 1 actually I know that what is the sum of all the numbers, actually the index is actually prime, and the sum 2 actually all the remaining numbers. Okay, so ultimately I return the absolute value, so absolute value of sum 1 minus sum 2. Got it? This is clear. I have shared this in the description, you can check that, and if not subscribe, please subscribe channel. Thank you. Bye.